So today we're going to cover acids and bases and their fundamental properties and how they're used in the real world. So what is an acid? Typically when most people think of acids, they're thought of as an extremely dangerous substance. However, this is not always true, and there are many safe acids in the real world, such as citric acid, which is found in many grapefruits. Basically, there are three definitions that we attribute to acids that were theorized by chemists long ago. The first definition is by Arrhenius, which states that any substance that increases the concentration of hydrogen ions within a substance is considered an acid. Then there's the Bronsted-Lowry definition, which basically says any substance that is a proton donator is a acid, such as H+, which is basically just a proton. Then there is the Lewis definition, which states that any substance that accepts an electron pair to form a covalent bond is an acid. Such as they are usually sour, they turn litmus paper red. When they reacted with the base, they produce a salt and water, although this salt is not always the typical NaCl that most people are used to. And acids also conduct electricity in solution. They interact with on the day-to-day include acetic acid and vinegar, citric acid in grapefruits, and hydrochloric acid that's actually in your stomach that helps you digest many foods. Some fun facts is that there's an acid in milk called lactic acid, and in Latin, milk is translated to lac. Agraugia is a very powerful acid. This one is probably not something you come in contact with at all. The terminology is taken from Latin. It means rural water because it can actually dissolve gold. The vitamin C we use is also an acid by nature, and the chemical name of vitamin C is ascorbic acid. And lastly, powerful acid is used to clean up the jewelry and remove surface imperfections. So that kind of goes back to the dissolvement of gold. Acids are very good at removing surface impurities, such as with silver, the greening that occurs. Next up is a base. And when you think of bases, you probably don't think of danger. However, bases in and of themselves can also be extremely dangerous when you reach the far end of their scales. One example of this is common household bleach. And many people know bleach is something you don't want to come in physical contact with. Just like acids, there are three ways to define a base, all from the same chemist. One is that it increases the concentration of hydroxide ions. It's also a proton acceptor, so the inverse of an acid. And then finally, it donates an electron pair. So you can think of a base as a literal inverse of an acid. So some common properties of bases include that they're bitter, they turn red litmus paper blue, again an inverse, they're slippery, that's why many soaps are slippery. Again, when they react with an acid, they also produce a salt and water, and like acids, they conduct electricity in solution. Some common bases and also fun facts about bases. There's sodium bicarbonate, which is in baking soda. There's ammonia, which is used as many household cleaners. And then there's sodium hydroxide, which is used to make various soaps. Fun facts, sodium hydroxide, again, is used in the manufacturing of soap. Ammonium hydroxide is used to remove ink from clothes and remove grease from windows, such as a cleaner. All alkalis are bases, but not all bases are alkalis. And then baking soda can be used to fight fires by obstructing the flow of oxygen. Okay, so next topic is ion concentration, which basically lets you determine pH and pOH. It refers to a concentration of H3O plus and HO negative molecules that are produced by acids and bases. It's labeled by the two terms pH and pOH. And it is also important to note that in formulas H3O is the same as H plus, and that the hydrogen ion is simply attracted to an unionized water molecule to form the hydronium. These formulas down here are pH equals the inverse log of H plus, pOH is the inverse log of H3O plus, and then something to note is that when these two are added together, they must equal 14. So if you can determine one, you can determine the other, and if you know the concentration of H plus or H3O, you can determine pH or pOH. Another topic we want to cover is the pH scale. And the pH scale basically lets you get a rough estimate of how basic or acidic a substance is. It ranges from 0 to 14. Anything below 7.0 is acidic, and anything above 7.0 is basic. And if you have a pH of exactly 7.0, you have a neutral substance. As you see on the two bottom scales, you can get various substances having various pHs that you also interact with on the day-to-day, such as tomatoes having a more acidic pH, and then all the way on the far end of the scale where you have something like bleach, which is very basic. Next is an acid-base reaction, which basically is a double replacement action between an acid and a base. And the chemical process is when hydrogen ions are exchanged, and it often takes place in water solutions. So if we watch this experiment down here, it's of one of my partners doing an acid-base reaction with common household items that you can even do yourself. So basically what he's doing is he's mixing NaHCO3, which comes from baking soda, with C2H4O2, which comes from vinegar, which releases carbon dioxide and then causes bubbling. Neutralization reactions are basically when strong acids and bases are mixed together to neutralize their properties. When the H plus cation combines with the OH negative anion, they form water. Cation from the acid forms salt with the anion of the base. That compound is then called a salt, and the combination has a pH of 7, which indicates that it's neutral. Ignition neutralization reactions, products lose their characteristics. There's no excess hydrogen or hydroxide ions present in the solution, which means they become neutral. Furthermore, some real-world examples include antacids. They react with the excess acid in your stomach that caused you the pain in the first place, and that decreases the amount of hydrochloric acid. And again, bacteria change the sugar on our teeth into acids, which causes tooth decay. The alkaline in the toothpaste neutralizes the acids, so tooth decay can be prevented. Titrations. Titrations are an interesting subject. Basically, a titration is the slow addition of a solution to another solution until the reaction reaches neutralization. If you mix a titrant with a known concentration with a solution of an unknown concentration, it's indicated by color change and often used to determine the concentration of an unknown substance. The diagram on the left basically shows you how you can kind of picture a titration of an acid with a base. Furthermore, on titrations, some real-world examples are pharmacists use titration to create a mix of compound drugs. They use it through an intravenous drip to get the correct proportion of different medicines. In biology, it is used to anesthetize test animals by mixing solutions to get desired compounds.